Good morning, everyone. Warmly welcome to a new ADF Spotlight session with two topics today. My name is Volker Linz, and I'm hosting and facilitating this community webcast series. Generally, I work as a Fusion middleware sales consultant at Oracle Germany, and I would shortly introduce the presenters and their topics. So first, Frank would be start. Frank Houweling from AMIS. Talking about the ADF performance tool, and afterwards his talk we have a 5 minutes Q&A. After the Q&A we have maybe a short break, but I don't know if it's work. And around 9 Danilo and Andreas will start with his talk about adaptive case management implementation best practices. Before Frank is going to talk, I would like to point out some guidelines. So if you have any questions, please use the chat and give also feedback after all the talks. And at the end of all the presentations, so at the end of Frank's presentation, we will wrap up your posted questions, and we would like to reply to them of all. If we couldn't make it at all, so we will have a Q&A FAQ document, which we will post it afterwards on the OTN community ADF Spotlight Mediathek. We ask for your understanding that all your lines are muted during this session. During Q&A, you can unmute yourself with #6, and afterwards, please mute your line with *6. So I'm passing over now to Frank, so you can start.
Okay, thank you, Volker. Hello, everybody. Welcome to this ADF Spotlight session on the ADF Performance Monitor. I'm Frank Houweling. I'm a senior Java and ADF specialist, a SOA specialist from AMIS in the Netherlands. And the last years I've focused on performance diagnosis and performance management. And I'm the lead developer within AMIS of the ADF Performance Monitor. What I will talk about today, I will give you a quick introduction. I'll give you an overview of all the features, and I'll spend most of the time with the demos. First of all, why would you want to have monitoring and instrumentation? Let's have a look how it looks in the real world. For example, in an airplane. Aren't you glad that the crew, the pilot of an airplane, does have a lot of instrumentation for safety? Would you like to trade it, the cost and the performance for safety? I think all of you have been in airplanes, and I think it's worth the cost, of course, to instrument and see what is going on. And particularly for applications, web applications, your end users do not accept slow applications anymore currently. If you monitor, you can see, is your application running as it should? Are your response times within the SLA agreement? And are there errors? And what is the type of errors? One way of seeing how your performance of your application is, what is the situation, is to call and ask your end users. But then you need a whole call center, and this is quite time consuming. The better way is to instrument your ADF code. The ADF Performance Monitor uses a lot of stopwatch metrics classes that can be plugged into the ADF framework. And it makes use of several extension points, like, for example, the ADF Business Component extension classes, data control classes, And also in the servlet API, there are a lot of listeners that you can implement, like HTTP event listeners or error event listeners, servlet filters. And this is how the ADF Performance Monitor works. So you attach an ADF library to your application, and all the instrumentation is in there. Then, after in the background grid, after request finishes, the metrics are saved into a database. They can also be written down directly during development to the JDeveloper console log window. First of all, I will give a demo overview of the main features. This is a project we are doing currently within AMIS, and what we see here is an overview, a day overview of the 9th of April, so a few weeks ago. On the left top side, we see all the HTTP requests that happened on this day, the number of errors, and we see some kind of service level agreement information, like all the HTTP requests that were quite slow, slow or normal. Also the errors are shown, and this is configurable, and of course the more very slow request you have, this is a trigger to drill down, and you can drill down, and I will come back to that later. You can drill down to that and see what is causing the delay. On the right top side, we see a bar graph of the day performance, and also with the same way of presenting that red is very slow request, yellow is slow request, and green is normal or fast request. And of course, the more red you see, in this case from 2 to 3, we see a lot of red, and this is a trigger, of course, to investigate and to have a close look at what is wrong. On the right bottom, we see the layer in which the time is spent. So in this case, we have 4 layers. We have a web service layer, a database layer, the application server, the WebLogic server layer, and the time in the network or browser load time, so in the client layer. And in this case, we see that from 2 to 3, that a lot of time is spent in the network and browser load time. Okay. On the left bottom, we see the JVM heap and garbage collection. And this is very important to have a close look at, because the memory consumption should be monitored. I will come back to that later too. Okay, right now I would like to drill down from 2 to 3, and we can do that by clicking on the bar in the menu. And now we have more details of what has gone wrong. We see in the graph at the right bottom that a lot of time is spent in the network and browser layer. And in this case, it was the browser load time of Internet Explorer that was causing the delay. We can even drill down more. And on the graph at the right top, we see individual HTTP requests. We see clearly that in some cases there were like 40 seconds of browser load time. Okay. So this is configurable. So we can configure how the monitor should interpret the HTTP request. So we can say like above 2000 milliseconds, we consider request as very slow. And everything between 1000 and 2000 milliseconds, we consider as slow, and everything faster than 1 second we consider as normal. We can configure many other things, which I will not explain now, but it is there. Okay, and I have one more example of the browser load time of one application where there was a lot of time being spent in the client layer. And what we see on the left is that most requests were spending something approximately like 9 seconds in the browser layer, which is quite a lot. And what we see here is an HTTP request overview of the worst performing requests. We see the time spent in the database, the server process time, the time spent in the client, the user ID, the organization, the component that was being clicked on, and the component type. We can also show a lot of other information like the managed server, the server URL, session details. That brings me to my second demo. The second demo is of another application, ADF application we have at AMS. And I want to go to a particular day because right now I'm in a month overview. And this dashboard application is a slightly older version, so the graphs are a little bit slightly different. And I would like to go back to the 16th of March. So I go back 1 month and I go to week 12, and then I go to Monday 16th of March. And what I see here on the right bottom graph is that there was a lot of garbage collection time, 83.3 seconds after 1 o'clock. And what we see here is more like a horizontal line, and this is often an indication that the heap space is set too low, or that the ADF application overconsumes the memory. That's also possible. Okay, so the monitor gives active warning signs. The second thing I want to show you is that a monitor, this is a test server, that the monitor can give you information of the worst performing parts of your application. For example, the worst performing ADF business components. So what I can do here is have a month overview of all the SQL calls, application module pooling, view get query, entity object DML operations, and application module transactions. This is sorted on average time. I can also sort on total execution time. So if you would like to have a look at the queries, for example, let's filter on view get queries. We see that there is one view object that is quite slow on average, but also in total. And we can drill down on this. We see that one time the view get query has taken nearly 60 seconds. And we can drill down to a so-called CallStack. And this CallStack is the most important feature of the ADF performance monitor. What it shows a complete breakdown of the request, starting at the application server, organized by the Fusion lifecycle phases, and all the steps within. So all the ADF business component executions, like for example this view object execution, and this is always called, a database action is always called by the execute query for collection method. In this case, we see the view object usage of pack D001am.plan_saldo VO. This is our view object usage name. And if we click on it, we see much more detailed information, like the bind variable. So you can reproduce this view object. Okay. This brings me to my next demo. This demo is on errors, and I go back to the same application. And to see an overview of all the application errors, I click on the error number. And what I see here is an overview of all the errors. And what we see here is an out-of-memory error. We see all kinds of database errors, and we can drill down on this. So we have the complete stack trace that we can copy and paste and send to ADF developers. But we also have the CallStack and the exact place where the exception happened. And in this case, we see that a DML update of an entity object called BTP header EO caused the exception. And for example, if this happens on production, you immediately want to solve this problem and let an ADF developer or database developer investigate this immediately. What we see here on the right is a time during an HTTP request. We see in a gauge, we see the percentage of the request. So we see exactly where the time is being spent. And in this case, we see that 1601 milliseconds is spent in the PO/SQL call. Warnings are given for slow or very slow database executions, but also for other inefficiencies. That brings me to my next demo. I have developed a demo application with built-in bottlenecks, and I will show you that right now. So I clicked on the search employees, and we see immediately that this is not the most fast application that you've ever seen. It takes a lot of time, and of course we really would like to know where is the time being spent. We see the application is fetching, and it takes ages before the final page loads. Right now, I would like to know where is the time spent. So I go to the ADF Performance Monitor. I log in. And right now I see it is 8:49, and I know the very last HTTP request was of me, so I can drill down. I can sort on descending, and here I see my HTTP request. It was 48 seconds. I can drill down on it, and here I see that, hey, there was an activation of the HR service that was causing the delay. And within the activation, I see that the activate iterator state of the employees view 1 was causing 7,200 milliseconds to run. And the root cause of this is the execution of the employees view object. So in this case, we can troubleshoot problems and see exactly what is going on. On the right side, we see the username, and in this application, there's no logging in, so the user is anonymous. But in real applications, you can see exactly who is clicking on what button or link, when, which managed server, how the GVM was on that time, which application server, URI, so you see everything. Okay. We can also click on the errors. And let's have a look one more. Let's go to locations. We see here that this also takes a while. And we see that an exception is coming. Let's go to departments. You see again an exception. And when I look so we can have a look at the ADF performance monitor. We can click on the refresh button and we see that the errors, this error has been logged as well. So right now, this is the way you can troubleshoot problems and see what is going on. And create your application, create a more stable ADF application. Okay. You can also monitor the loaded rows in memory. For example, on the right bottom side, we do see a lot of warning signals, and this comes from an application in production. When we look at the memory analyzer, I'm not sure that everybody can see it, but the blue part is coming from an ADF business component view object that was loading more than 900,000 rows. And we can see at the right top that how many rows it cached and loaded into the ADF application. And of course, this is not good for the memory consumption. There will be long garbage collections, and all users probably will have problems, delay from this. Here we see it in a CallStack that this was taking more than 10 minutes also to load all the 900,000 rows. The ADF performance monitor can be dynamically turned on and off at all times in the Enterprise Manager. And when the monitor is turned off, there's no performance overhead because the matters classes are not active. The monitor, the CallStacks, can also be used in development environment. They can be printed within JDeveloper simply by turning the level on to finest of the JDeveloper logger. And in the end, of course, you will save a lot of time and money. You can create a quality application, and your end users will be more happy with a stable, good performing ADF application. You can learn more on the AMIS site and on the AMIS blog. There is also a white paper And there's an overview video as well. And that brings me to the end of my presentation.
Thanks, Frank, for your lively demonstration of the ADF performance tool. And we have some we have a question.
Yes.
Could you tell what the performance overhead is if you turn it on in a live production environment or in the developer environment?
Yes, the performance overhead is something like 3 to maximum 4%, and this is caused by the detailed collection of the metrics. So we have all of our customers have the monitor in production, and there are several levels of settings that where you can configure how much you would like to log. Would you like very detailed logging, or do you want only have the details of the very slow requests? So there's a lot of configuration, but even when you are logging to the tiniest detail, there's a maximum 3 to 4%.
Mm-hmm. Okay. And how do I get the ADF performance tool? Could I download it, or should I send you an email to get it, or?
You can send an email to we have a special page on the AMIS site. It's amis.nl/ADF Performance Monitor, and there is all the information to contact and to order it as well. And then you can order by email to our my sales colleague.
Mm-hmm. And I also find the documentation there. There are the links.
Yes, there's a white paper there as well, and an overview, and more information, and also some links to blog articles I wrote.
Okay. I have one last question from a partner here in Germany. They don't use ADF BC. They are working with ADF phases and based on remote AGB and SOAP calls. So the business, on the business service layer, we have remote AGBs and SOAP web services. Do you also track this, or?
Yes. Yes. The monitor also supports EGBs. It supports POJO Java data controls. It supports JOX WS web services. And there's also the option of custom instrumentation. So you can, if you have a generic utility method or superclass where you can, where time is being spent and that is important, you can also instrument it, and it will show in the call stacks. So there's you can instrument every ADF application if you want to.
Okay. So there was also a nice feedback from a customer. It's a very nice tool we have implemented in the last weeks after a short try time. Nice work, Frank.
Okay. Oh, that's great. Great to hear. Yeah. Thanks.
Okay. We will post your slides on the OTN Spotlight community site, so that you can also, so maybe that any colleague of the audience could see your slides and see also recording of this session.
Sure.
I would like to thank you for your time, Frank, and for the fascinating presentation. And I think we should do a short break for only 1 minute or so. And when we switch over to the next topic, to ACM implementation best practices, and yeah, that's it. So we have a short break. Thanks for your time, Frank.
Thank you very much.
Bye.
Okay.